Okay, so today what we're going to talk about is measuring variability for symmetrical distributions. In example 1, they want us to calculate the standard deviation. It says, here's the dot plot of the lives of the brand A battery for level 4. So they want to know, how do you measure variability of this data set? One way is by calculating the standard deviation. The first step says, first, find each deviation from the mean. And it says, then, square the deviation from the mean. For example, when the deviation from the mean is negative 18, the square deviation is negative 18 squared, which is equal to 324. So the first thing we're going to do is we're going to first figure out what the mean is. So if we look at our data set up here, I can see that this one is about 82. This one is right before 95, so this would be 94. This one would be about 96. This one would be about 107. Our next data set would be about 113. And the next one would be about 114. So, if we needed to find the mean, so I'm just going to write the mean up here. Mean is equal to, then we would just add them all up. So 82 plus 94 plus 96 plus 107 plus 113 plus 114. And then we're going to divide by how many we have. We have 1, 2, 3, 4, 5, 6. So we'll divide by 6. If we add them all together, we get 606 divided by 6, and that would be 101. So we know that the mean is going to be 101. So now we have to figure out the deviations from the mean. So if we know our mean is 100 and we have 83, we're going to do 101 minus 83, and it would be minus 18. Because we have to take 101, subtract 18 to get 83. If we go on to 94, 101 minus 94 is 7, so we do minus 7. 101 minus 96 is going to be a minus 5. And then for the next one, since it's 106 and it's greater than 101, we're going to do 106 minus 101 would be a positive 5. 113 minus 101 would be a positive 12. Then we would do 101, or 114 minus 101 would be positive 13. And now what we have to do is we have to do the square deviation from the mean. So now we just have to take each one of these deviations from the mean and just square them. Remember, when you're squaring a negative in your calculator, you want to put it in parentheses, or else it's going to give you the wrong answer. So if you do negative 18 squared, it's going to be 324. Negative 7 squared is going to be 49. Negative 5 squared is going to be 25. 5 squared is going to be 25. 12 squared would be 144. 13 squared would be 169. So now what they want us to do is add up all the square deviations. So we're going to add all these up. So it will be 324 plus 49 plus 25 plus 25 plus 144 plus 169. And if you add all those together, you should get 736. So this result is the sum of the square deviation. So they say the next part is the number of values in the data set is denoted by n. So in this example, since we have six data in our line, we will have n will be equal to 6. But with the standard deviation, you divide the total sum of the sum of the square deviation, and you divide it by n minus 1. So if n is 6, n minus 1 would be 5. So you have to do 736 divided by 5, and that would come out to be about 147.2. So now it says, finally, you take the square root of 147.2, which to the nearest tenth would be 12.13. So if we take the square root of 147.2, it will be approximately equal to 12.13. So that would be our standard deviation. Once you take the square root, that gives you the standard deviation. So it says, that is the standard deviation. It seems like a very complicated process at first, but you'll soon get used to it. So we conclude that a typical deviation of brand A battery lifetime from the mean battery lifetime for brand A is about 12.13 hours. The unit for standard deviation is the same as the unit of the original data, so the standard deviation to the nearest tenth with the unit will be 12.13 hours. Okay? So now let's move on to the next example. So now let's look at exercise 1 to 5. So now it says, now you can calculate the standard deviation of the lifetimes for brand B. The mean was 100.5, and we already have the deviations from the mean. So all they did was just find it for us. So we have already the deviations from the mean. All they did was take 100.5, subtract 73 to get negative 27.5. They want to know what is the square deviation. So we're going to take this number for the deviation of the mean and square it. So if we take negative 27.5, again, if we're squaring it in our calculator, we want to put it in parentheses. If we square it, we'll get 756.25. If we square negative 24.5, we'll get 600.25. If we square negative 8.5, we'll get 72.25. If we square negative 6.5, we'll get 42.25. If we square 9.5, it'll be 90.25. If you square 16.5, it'll be 272.25. If you square 17.5, it'll be 306.25. And if you square 23.5, you'll get 552.25. So now they already told us to write the square deviation in the table. We did that. And they want us to add up the square deviation. What result do you get? Well, if I just add these all together, so I start with 756.25 plus 600.25 plus 72.25 plus 42.25 plus 90.25 plus 272.25 plus 306.25 plus 552.25. We're adding them all up, and if you add each one of these up together, you should get 2,692. Okay, so now they want to know for number 3. So if I added them up, they want to know what is the value of n for this data set. Well, we know n is the number of data sets that we have. So if we go back to our table, we can just count up our data sets. 1, 2, 3, 4, 5, 6, 7, 8. But remember, when we're dividing, we're going to divide by the n minus 1. So we know that n minus 1 is going to be 8 minus 1, which is 7. So we're going to take this 2,692 and we're going to divide it by 7. Okay, so they said divide the sum of the deviation, so we got 2,692, divided by n minus 1, which would be 7. And they want us to write our answer below, and they want us to, afterwards, round to the nearest 1,000. So if I divided 2,692 divided by 7, I would get 384.5714,286. But they want us to round to the nearest 1,000, so we go 10th, 100th, 1,000. So it would be about 384.571. So then after we get that, we need to take the square root of, to find the standard deviation. So we take the square root of 384.571. And they want us to round our answer to the nearest 100. So if we get that, it would be approximately equal to 19.61 hours. So they want to know for number 5, how would you interpret the standard deviation that you found in exercise 4? And it says, remember to give your answer in the context of this question and interpret your answer to the nearest 100. So if we look at this, we know that the standard deviation is 19.61 hours. And we know that that standard deviation is a typical deviation of brand B. typical deviation of brand B. Lifetime from the mean lifetime of brand B. So that is how we can interpret the mean or the standard deviation of brand B batteries. So the standard deviation for this problem set was 19.61, and that's a typical deviation of brand B lifetime from the mean lifetime of brand B. Okay? So now let's move on to the next problem. For exercise 6, they say, Jenna has bought a new hybrid car. Each week for a period of 7 weeks, she has noted the fuel efficiency in miles per gallon of her car. The results are shown below. So 45 miles per gallon, 44 miles per gallon, 43 miles per gallon, 44, 45, 44, and 43. Again. So they want us to calculate the standard deviation of these results to the nearest hundredth. And be sure to show all your work. So to do this, what we're going to have to do is follow all the steps that we did before. So in order to do that first, we want to first calculate the mean. So, to calculate the mean, we're going to add up all these numbers and divide by the number that we have. So we have 1, 2, 3, 4, 5, 6, 7. So I'm going to add them all up first. So 45 plus 44 plus 43 plus 44 plus 45 plus 44 plus 43, and we're going to divide by 7. We want to check to see that we have 7 numbers. 1, 2, 3, 4, 5, 6, 7. So if we add them all up, we will get 308 divided by 7, which will be equal to 44. So we know that our mean is 44. So now we want to figure out our deviations from the mean and then our square deviations. So we can come up with our actual numbers. So we can just make that chart. So we can do a little chart. We could do the deviation from the mean. And then we're going to also do the square deviation from the mean. So if we look at this, since we have 7 data values, we're going to have 7 deviations from the mean. So we just want to make our boxes. And if we were trying to find the deviation from the mean, well, how do we get from 45 to 44? We subtract 1. Or from 44 to 45, we're going to add 1. So this would be a positive 1. From 44 to 44, we have 0. From 44 to 43, we subtract 1. 44 to 44, we subtract 0. 44 to 45, we add 1. 44 to 44, we subtract 0. 44 to 43, we subtract 1. So now what we want to do is we want to come up with the square deviation. So we're going to do 1 squared, which is 1. 0 squared, which is 0. Negative 1 squared, which is positive 1. 0 squared, which is 0. 1 squared, which is 1. 0 squared, which is 0. Negative 1 squared, that's 1. Now what we want to do is we want to add up these square deviations. So I'm going to add them up. So I have 1 plus 0 plus 1 plus 0 plus 1 plus 0 plus 1. So all I'm adding up is the whole square deviation. Nothing with the deviation from the mean, but all of these squares deviation, I'm going to add them all up. If you add all these up, so 1 plus 0 plus 1 plus 0 plus 1 plus 0 plus 1 would just be 4. And we know that n is equal to 7. And we want to divide this 4 by n minus 1. So n minus 1 would then be 6. So to find our deviation, we're going to do 4 divided by 6, which would be equal to about 0.667 to the nearest thousandth. And then we have to take the square root of this to find our standard deviation. So we do the square root of 0.667, and they say that we want to round to answer to the nearest hundredth. So this would be approximately equal to 0.82 miles per gallon. Okay? And then for number 7, they want to know what is the meaning of the standard deviation found in 6. So if our standard deviation is 0.82 miles per gallon, that means that the standard deviation of 0.82 miles per gallon is a typical deviation of a weekly fuel efficiency value from the mean weekly fuel efficiency. Okay, so it's, anytime we find the standard deviation in a problem, it's always a typical deviation of whatever we have from the mean of whatever we have in the problem. Okay, so let's look at this lesson summary. So it says the standard deviation measures a typical deviation from the mean. So that's what I just said. So anytime we have standard deviation, it measures a typical deviation from the mean, or how much change we have, or how far away we are from the mean. So it says to calculate standard deviation, they want us to find the mean of the data set first, then calculate the deviation from the mean, then square the deviation from the mean, then add all those squared deviations together, then divide by n minus 1. So if we're working with the data with a sample, which is the most common case, we're always generally coming up with a sample. We never use the population in this course. And then number 6, if you take the square root and probably round to the nearest hundredth. So what I want you to do is I want you to star this, because this is what you have to memorize for finding the standard deviation. They're not going to give you these steps. You're going to have to memorize them. And then it also says that the unit of standard deviation is always the same unit of the original data set. And it says the larger the standard deviation, the greater the spread or the variability of the data set is, which we saw in the last problem set that we did in 2-4. Okay? And that will be the end of this lesson.